Bismillahirrahmanirrahim. Today I'm going to discuss about chemoselectivity in organic synthesis. These are the key concepts. First of all, I will discuss about selectivity. What is selectivity and what are the types of selectivity? Then I will discuss about chemoselectivity in detail. Selectivity. In most organic molecules contain more than one functional group, and most functional groups can react in more than one way. So, uh, most organic chemists have to predict which functional group will react and where it will react and how it will react. All these questions are called selectivity. Selectivity comes in three sorts: chemoselectivity, stereoselectivity, and regioselectivity. First of all, I will discuss about the regioselectivity. For example, we have a reagent and it will react on a substrate and we will get the product. Now that reagent will specifically react on a specific specific position of the substrate. That is called regioselectivity. Means where the reagent will react. In this, we have studied the examples of addition reactions, in which we have already discussed about the Markovnikov's rule. In addition reactions, for example, the addition of HBr, the addition of hydrogen occurs at a specific carbon atom, while the addition of bromine occurs at the other carbon atom. While stereoselectivity is how the group reacts with regard to the stereochemistry of the product. In this, two stereoisomers can be formed, or it can lead to the enantiomers or distereomers. So we will discuss it in the later lecture. Now come towards the chemoselectivity. Chemoselectivity means in which group reacts. If we have two functional groups in a substrate, then the reagent will react at which functional group. Actually, chemo means the chemistry. So here we will discuss about the chemistry of the reaction, how the reaction takes place, or in which group the reagent will react. Let us discuss in the next part of this lecture. Chemoselectivity. A chemoselective reaction is a reaction in which a reagent reacts with one functional group in preference to another. Here beta, the reason of reaction is functional group. Actually, in organic reactions, at which place the reaction takes place. The reaction takes place always at the functional group. So the reaction will occur due to the presence of different functional groups, and these different functional groups will be very selective for the reaction to react with particular substrates. For example, in reduction reactions, you have studied different reducing agents like lithium aluminum hydride, sodium borohydride, diisobutyl aluminum hydride, catalytic hydrogenation, dissolving metal reduction, etc. Here I have quoted only one example of the reduction of, in fact, selective reduction of aldehydes and ketones. In this reaction, there are two functional groups. One is ketone and the other is aldehyde, while the reducing agent is sodium borohydride in presence of isopropyl alcohol. Here, this sodium borohydride or NaBH4 will selectively reduce the aldehydic carbonyl group, while it will not reduce the ketonic carbonyl group. This reaction is a very good example of chemoselectivity. Let us see how this will occur in the further examples. There are some strategies among which we will discuss the three one. If a molecule has two reactive groups and we want to react one of them, not the other, we need the chemoselectivity. Actually, when we have two different functional groups, the reactivity of the two functional groups will vary. Their reactivity towards a single substrate will compete with each other. So the relative reactivity of two different functional groups, for example, here is the example in which the two functional groups are NH2 and OH group. The reaction of one of two identical groups. We might want to make the monoether. Here is the example. If we have the same functional groups, but two times, means we have two identical functional groups, then how this will react? Then how can we react only one of the functional group out of the two same functional group or two identical functional group? The third case is the reaction of a group once, when it may react again, or this is an example of you have might studied in the oxidation of alcohols. When the alcohols are oxidized in presence of chromic acid, the reaction does not stops at the um, aldehyde or ketone. The reaction proceeds towards the carboxylic acids or esters. Means one functional group can react twice with the reagent. Here is the example of synthesis of thiols. We will discuss these examples step by step. In Guideline 1, if two groups have unequal reactivity, the more reactive can be made to react alone. Here the question is the more reactive. More reactive means we will check its electronegativity or the uh, feasibility to react with the substrate. First of all, here is the example of paracetamol, in which the benzene ring contains the OH group along with the amide group at its para position. First of all, we will discuss its retro-analysis. In retro-analysis, the C-N disconnection will occur and the amide linkage will be disconnected, after which we will get the NH2 group. It's as we can't introduce NH2 group directly, so it will be interconverted into some other functional group that can be attached directly. So NH2 will be converted into nitro group, and the next step is the disconnection of the CN group again, that is the nitration of the phenol. Now amines are more nucleophilic than phenols, so reaction with acetic anhydrides gives the amide we need it without any of ester. Now, if we want to synthesize this paracetamol, the pathway of the reaction will be like this. The phenol will react with the diluted HNO3 and its nitration will occur, which will be reduced to the NH2 group. Now the question of selectivity comes at this point. Here the phenol should we have to keep the phenol unionized so that NH2 will be more reactive than OH, because ammonia is more nucleophilic than water but less so than OH ions. Here students, you can see the electronegativity difference or the effect of the conjugate base. Ammonia or NH2 will be more nucleophilic towards the acetylation, while the OH group of the phenol is less electrophilic. So it will not react with the acetic anhydride, means it will react selectively. Here the point of chemoselectivity is that there are two different functional groups and the reagent is acetic anhydride. Here the competition will be between the NH2 and OH of the this molecule, whether the OH will react and will form an ester, or the NH2 will react and will form the amide linkage. So as the amines are more nucleophilic, so the NH2 group will react with the acetic anhydride to give the target molecule in 79% yield. Synthesis of cyclomethycaine is another example of the substrate having two different functional groups. Here the selectivity comes between two oxygen nucleophiles. It might be difficult, but when one is alcohol and the other is carboxylic acid, then there will be no problem. How, let us discuss how this retroanalysis or this synthesis can be carried out. In previous example, we had two different functional groups. One was NH2 and the other was OH. Their reactivity was very different. In this example, as you can see the ester linkage, we will disconnect. If we do its retroanalysis, this ester linkage will be disconnected, and after CO bond disconnection of ester group, we will get this first retro product, which contains the carboxylic acid at the benzene ring along with an ether linkage at the para position with the cyclohexane. In second step, this ether linkage will also be disconnected as the CO ether, and we will get the starting material as benzene having the hydroxy group at the para position along with carboxylic acid group at the para position of OH. Here the question of chemoselectivity arises as we have two different functional groups, and the competition of reaction with the substrate with the reagent of the two different functional group is arising. Here the OH group again is less reactive towards the esterification. If we need to react the less functional group with the reagent, then we have to protect the more functional group, more reactive functional group with the with any protecting groups. For example, in previous example, as we have to protect the amino group, then this can be protected through the formation of the amide. and here this carboxylic acid can also be protected with suitable protecting group, and alcohols can also be protected through the formation of the acetols. Ketones can be protected through the ketols. There are different functional groups, and these will be discussed in, there is a separate lecture on the protecting groups. Here is the synthesis of this anesthetic. The question is, will the hydroxy acid react only at the OH group, or will the COOH group reacts also too? Here are the two different functional groups, and we need to react both of these functional groups with two different reagents. Now the question is, which functional group will react first, or which functional group is more reactive towards the reagent? Here, first of all, as I have already told you, that we will disconnect that functional group later, which we have to add first during the synthesis. हमें जो functional group या जो group सबसे पहले ऐड करना है उसको हम सबसे बाद में डिस्कनेक्ट करेंगे. And as you have seen, I have disconnected the cyclohexane group of ether linkage in the last. So during synthesis we have to add this ether link, this cyclohexane group with the ether linkage first in the during the synthesis. So when we discuss its synthesis in alkaline solution, when both are ionized, the phenolate ion is much more reactive than the carboxylate ion, and only the phenol is alkylated. Here the question of chemoselectivity is solved, that when we carry out this reaction in the presence of a base will abstract a proton, and a carboxylate ion will be formed along with the phenolate ion, and the phenolate ion is much more reactive. Its reactivity is high, that's why this phenolate ion will be alkylated with the alkyl iodide group. Here the alkyl iodide group is used as the secondary alkyl derivative. So iodide is a better leaving group than the chloride or bromide. In the first step of synthesis, the OH group is chemoselectively alkylated by the alkyl iodide or cyclohexyl iodide as compared to COOH group, because it was less reactive as compared to the OH group. The second point was, when one functional group can react twice, the starting material and the first product will compete for the reagent. The reaction will be successful only if the first product is less reactive than the starting material. बेटा sometimes ऐसा होता है कि एक रिएजेंट ने एक सबस्ट्रेट पे रिएक्ट किया है, उसके नतीजे में हमारे पास जो प्रोडक्ट बनी है वो दोबारा से compete करेगी विद द स्टार्टिंग मटेरियल. वो फिर उसी स्टार्टिंग मटेरियल के साथ रिएक्ट करके फर्दर एक नई प्रोडक्ट बना देगी. इसके एग्जांपल है ऑक्सीडेशन ऑफ अल्कोहल्स. अगर हम अल्कोहल्स की ऑक्सीडेशन करवाएं क्रोमिक एसिड के साथ, तो हमारे पास पहले स्टेप में जो है वो एल्डिहाइड या कीटोन बनेगा, लेकिन वो एल्डिहाइड और कीटोन वो compete करेंगे विद द अल्कोहल टू रिएक्ट विद क्रोमिक एसिड, और उसके नतीजे में हमारे पास जो है वो फर्दर उसकी ऑक्सीडेशन होगी उस एल्डिहाइड और कीटोन की, और हमारे पास एक कार्बोक्सिलिक एसिड या एस्टर बन जाता है। इसलिए ये बहुत इम्पॉर्टेंट है ऑर्गेनिक सिंथेसिस में कि हमें रिएक्शन को स्टॉप करना पड़े at the first product. Then the reaction will stop cleanly after the starting material is more reactive than the product. अगर तो starting material product से first product से ज़्यादा reactive है तो हम उस reaction को stop कर सकते हैं। इसके लिए हमें ऐसे substrates या ऐसे reagents यूज़ करने पड़ेंगे जिसके नतीजे में जो फर्स्ट प्रोडक्ट बनेगी वो दोबारा से रिएजेंट के साथ या दोबारा से स्टार्टिंग मटेरियल के साथ रिएक्ट ना कर सके और हमारा रिएक्शन फर्स्ट स्टेप पे ही स्टॉप हो सके। तो इसके लिए एक एग्जांपल है बेटे, हियर द सिंथेसिस ऑफ thiol. This thiol can be prepared by the reaction of H2S gas in the presence of a base. अब एक बेस की प्रेजेंस में जब H2SO4 को बेस के साथ ट्रीट करवाया जाएगा तो हमारे पास HS उसके ऊपर नेगेटिव चार्ज बनेगा। इस SH को एनाइन को हम ट्रीट करवाएंगे विद अल्काइल ब्रोमाइड के साथ। एज वी नो ब्रोमीन इज अ गुड लिविंग ग्रुप, ब्रोमीन निकल जाएगा और हमारे पास RSH निकल जाएगा। अब RSH हमारे पास फर्स्ट प्रोडक्ट है जबकि SH माइनस भी स्टार्टिंग मटेरियल के तौर पे रिएक्शन मिक्सचर के अंदर पड़ा हुआ है। दिस SH starting material and RSH which is the first product, both of these will compete to react with the alkyl bromide. In the second step, you can see when a base will abstract a proton from RSH and it will form RS minus, while the SH will also lose another proton and or the H2S is the starting material, so it will again lose a proton and it will form SH minus. Both of these, starting material and first product, will compete to react with the alkyl bromide. Here, if we need RSH as the single product, we can't achieve this if this RSH will compete for the reagent. Now in the second step, this RS with negative sign will again react with bromide and we get the RSR reaction product. This is the synthesis of thiol. While in the second example, the acid chloride with the phenyl group, here first of all we will see its retroanalysis. In retroanalysis, the CO linkage will be break between the carbonyl group and the O group of ether linkage, and we will get the benzyl alcohol and phosgene gas COCl2. Here this phenyl group benzyl alcohol will compete to react with the phosgene gas, while this is the first product. This phenyl CH2OH group will further try to react with the reagent, while the starting material that is ROC double bond OCl, it will be ionized or it will undergo in the resonance, so it will not react with the reagent further to give the second product of the reaction. This reagent is used in the protection of the amino group. We will discuss it in the other example. Guideline 3. Here is the application of the previous acid chloride functional group. In the case of amino acids, if we need to react the carboxylic acid and not the NH2 group, then we have to protect the NH2 group by some suitable protecting group. Here, the if we want to react the less reactive of two functional groups, we protect the more reactive. If we want a reagent to react once when it could react twice with, we protect the reagent. A protecting group is something added to the functional group that reduces or eliminates unwanted reactivity. Beta, actually, this example is the in this example we will discuss the unfavorable cases from guideline 1 and 2. As in guideline 1 and 2, in 1 there were two different functional groups, and this amino acid is going to present that example कि अगर हमारे पास दो डिफरेंट फंक्शनल ग्रुप्स ऑफ डिफरेंट रिएक्टिविटी के फंक्शनल ग्रुप्स हैं, उनमें से हमें मोर रिएक्टिव फंक्शनल ग्रुप को रिएक्ट नहीं करवाना, हमें लेस रिएक्टिव फंक्शनल ग्रुप को रिएक्ट करवाना है, तो उस केस में हम क्या करेंगे? उस केस में हम जो लेस मोर रिएक्टिव फंक्शनल ग्रुप है उसको प्रोटेक्ट करवाएंगे विद सम प्रोटेक्टिंग ग्रुप, एंड द फर्स्ट प्रोडक्ट जो बनेगी वो फर्स्ट प्रोडक्ट विल रिएक्ट विद द desired reagent. As in this example, amine is more nucleophilic than the carboxylic group, so we use benzyl chloroformate to protect the amine. Now in this case you can see, dear students, that the NH2 group is protected in the form of amide, and we know amides are less reactive than the amines. So here the COOH group is free to react with any reagent. Why amides are less reactive? In the corner the structure is shown that the lone pair of nitrogen is involved in resonance with the carbonyl group adjacent to it. That's why this lone pair of nitrogen is involved in resonance, so it will not be available anymore to react with any reagent. That's why the NH2 group becomes less reactive or inactive, or it is protected, while the COOH group will be available for the reaction. Here is another example when of the point that one functional group can react twice. This is the example of thiols, synthesis of thiols, RSH. By direct alkylation of H2S is not a good approach, as the product is at least as reactive as the starting material, as we have seen in the previous slides. So the thiourea is used as a masked H2S equivalent. To obtain the thiols, we will change the strategy. We will use some another reagent as a masked reagent to obtain the desired product. So here the thiourea is used and the thiouronium salt is formed, which is being unable to react further and easily hydrolyzed to the thiol. In this example you can see thiourea reacts with the R alkyl bromide, and the first reagent is formed, which is thiouronium salt. This thiouronium salt will react with it will be hydrolyzed to the urea, and we get RSH as the sole product of this reaction. मतलब ये है कि अगर हमारी जो रिक्वायर्ड प्रोडक्ट है
उसमें वो हमें हासिल नहीं हो रही है थ्रू अ सिंगल स्टेप। उसमें स्टार्टिंग मटेरियल compete कर रहा है, सॉरी फर्स्ट प्रोडक्ट compete कर रही है स्टार्टिंग मटेरियल के साथ। तो हम कोई और रिएजेंट एज अ स्टार्टिंग रिएजेंट ले सकते हैं जो कि जिसकी फर्स्ट प्रोडक्ट compete ना करे रिएजेंट के साथ या स्टार्टिंग मटेरियल के साथ, और हमें जो है वो सिंपली फर्स्ट प्रोडक्ट ऑब्टेन हो जाए। Here is another example of captodiamine. Captodiamine is used as a sedative and tranquilizer. This is another example of the some kind of synthesis of thiols. First of all, we will see its retroanalysis. In retroanalysis, the CS bond of the sulfide or thio linkage, thioether linkage actually ये, this bond will break and we will get the SH group. And to treat this SH group, how it will react with the starting reagent to obtain the target molecule. Let us see in the next. Here is the second step of the retroanalysis of the thiol. Again the CS bond will be disconnected and we will get the phenyl chlorine with the phenyl group, and again in the second step this chlorine group will be changed into the OH group. This OH group will be changed through the functional group interconversion into the ketonic group. This ketonic group will be removed or disconnected through the C.C.-Friedel-Crafts alkylation or acylation, and in the last step this butyl sulfur group will also be disconnected. So this was all about the retroanalysis of this captodiamine, and we will now see its synthesis, and we will check how during its synthesis these guidelines or the chemoselectivity arises during its synthesis. Here the benzene thiol is available commercially, so we will not disconnect it for further. So we will use it as the starting material to synthesize this captodiamine. Let's discuss its synthesis. When we talk about the synthesis of captodiamine, the first benzene thiol is commercially available. It will need only a weak base, as benzene thiol is acidic and electron donating. Butyl sulfur group is directs the para position. Butyl chloride will react with the benzene thiol to obtain the phenyl butyl ether or thioether. It will further will be esterified or through the Friedel-Crafts acylation. एक्चुअली इसकी एसाइलेशन होगी और ब्यूटाइल सल्फर की पैरा पोजीशन पे जो है वो एक एसिटाइल या बेंजोइल ग्रुप, एक्चुअली ये बेंजोइल ग्रुप अटैच होगा. It will further reduced through the sodium borohydride and we will obtain the OH group as we have seen in the previous retro analysis. This is actually FGI approach. हम इसमें FGI approach इस्तेमाल करेंगे. उसके बाद ये change होगा. This OH group will be replaced with the chlorine group which will act as the good leaving group. This reaction, this compound will react with the thiourea in the presence of a base. Now this base, when this thiourea will react with this compound, and we will get the SH group, insertion of SH group, same as I have discussed in the previous slide through the thiourea salt. thiourea salt के जरिए sulfur group, SH group will be introduced in place of this chlorine. Here this is the application of previous example कि हमने वो जो थायोल्स या थायोयूरेनियम साल्ट बनाया था उसको हम क्यों और कैसे या कहाँ इस्तेमाल कर सकते हैं. तो बेटा this SH group will further react with the chloro and dimethylamine propane है actually ये, and we will get the starting material, or sorry, we will get the target molecule. Through this whole scheme, it shows the application of the guideline when one functional group can react twice. The starting material and the first product will compete for the reagent. ये हमें ये शो कर रही है कि किस तरह हम अपनी सिंथेसिस को प्लान कर सकते हैं, अपनी सिंथेसिस को डिज़ाइन कर सकते हैं किसी भी कंपाउंड की अगर हमें टारगेट मॉलिक्यूल तक पहुंचना है तो. Here is the second strategy, reaction of one of two identical functional groups. When two identical functional groups are present, then how one of these two can be reacted and the other one is kept unreacted. One of two identical groups may react if the product is less reactive than the starting material. इसमें फिर ये बताया जा रहा है बेटा कि अगर हम इक्विवेलेंट मोल्स यूज करते हुए रिएजेंट के दो सेम जो रिएक्टिंग ग्रुप्स हैं उनमें से किसी एक का रिएक्शन करवाएं और दूसरे को हम जो है वो ना करवा सकें, तो हमारे पास क्या होगा, इफ द प्रोडक्ट फ्रॉम फर्स्ट रिएक्शन इज लेस रिएक्टिव then the starting material double reaction may be avoided. अब ये जो पहले स्टेप में हम एक सिंगल रिएक्शन ग्रुप को रिएक्ट करवाते हैं, उसके नतीजे में जो प्रोडक्ट बनती है वो लेस रिएक्टिव हो, तो हमारे पास ये एक यूजफुल वे होगा ऑर्गेनिक सिंथेसिस में. कैसे? फॉर एग्जांपल आपने नाइट्रेशन ऑफ बेंजीन पढ़ा होगा. जब हम बेंजीन की नाइट्रेशन करते हैं हमारे पास मोनोनाइट्रेशन प्रोडक्ट बनती है, उसकी अगर फर्दर हम नाइट्रेशन करवाएं तो हमारे पास मेटा डाइनाइट्रोबेंजीन बनती है. अब हमें अपने किसी भी जगह पे किसी सिंथेसिस में दो नाइट्रो ग्रुप चाहिए और उनमें से हमें एक यूज करना है आगे फर्दर और दूसरा नहीं यूज करना, तो उसके लिए हम क्या करेंगे, उसमें हम ये वाली स्ट्रेटजी अप्लाई करेंगे. अब यहाँ पे देखिए कि दो नाइट्रो ग्रुप हैं, उनमें से वन ऑफ द नाइट्रो ग्रुप इज रिड्यूस्ड into the NH2 group while one nitro group is not reduced. So here the two groups are जो है वो उनकी रिएक्टिविटी डिफरेंट हो गई है. Partial reduction of meta dinitrobenzene this reduction involves the acceptance of electron from the reducing agent. So in this case we get the one nitro group reduced. This example is the application of the previous strategy of one of the two identical groups if we have, and one of these groups may react to obtain the product, and the product is less reactive than the starting material. In this example, if we do its retro analysis by disconnecting the N bond, CN bond of the naphthol group, CN diazotization coupling, we will get the beta naphthol, and the other is the meta nitroaniline. Now this meta nitroaniline हमें किस तरह से इसको हम अप्लाई कर सकते हैं बेटे, जब हमें ये डाई सिंथेसाइज करनी है, उसके लिए हमें क्या चाहिए, उसके लिए हमें एक बीटा नेफ्थोल चाहिए, ठीक है, और हमें एक मेटा डाइनाइट्रोबेंजीन चाहिए। उस मेटा डाइनाइट्रोबेंजीन की हम रिडक्शन करेंगे और एक नाइट्रो ग्रुप, one nitro group will be changed into NH2 group, और हमारे पास ये मेटा नाइट्रोएनिलीन बन जाएगा। इस मेटा नाइट्रोएनिलीन को हम फर्दर ट्रीट करवाएंगे HNO2 के साथ, यानी कि इसकी डाईएजोटाइजेशन होगी। आफ्टर डाईएजोटाइजेशन we will get this meta nitro diazonium salt. This meta-nitro-diazonium salt will react with the beta-naphthol. तो इस तरह से ये जो एक एप्लीकेशन है, ये द स्ट्रेटजी ये अप्लाई होगी किसमें, इन ऑर्गेनिक सिंथेसिस ऑफ डिफरेंट कंपाउंड्स और इन द सिंथेसिस ऑफ सोलुबल डाइज। अब आप ये देखिए कि पहले स्टेप में डिस्कनेक्शन में हमने क्या किया, डाईएजोटाइजेशन वाला जो CN डिस्कनेक्शन है वो ब्रेक किया, और उसके बाद हमने जो है वो सल्फोनेशन बीटा नेफ्थोल की कराई। तो अगर हम इसकी सिंथेसिस की बात करें बेटा, तो पहले हम बीटा नेफ्थोल की सल्फोनेशन कराएंगे, उसके नतीजे में हमारे पास प्रोडक्ट 18 बनेगी, and this 18 will react with the meta-nitro-diazonium salt which is labeled as 19. इस 19 के साथ रिएक्ट करेगी, तो हमारे पास जो है वो प्रोडक्ट जो है दोबारा से 17 एज अ टारगेट मॉलिक्यूल बन जाएगी। So this was all about the 3 strategies used in chemoselectivity. हम इन एग्जाम्पल्स के ज़रिए ये देख सकते हैं, हमने ये बल्कि देखा कि किस तरह से 2 फंक्शनल ग्रुप्स अगर मौजूद हैं एक सबस्ट्रेट के अंदर, तो किस तरह से हम उनमें से किसी एक को ऑर्गेनिक सिंथेसिस में अप्लाई कर सकते हैं या उसको यूज़ कर सकते हैं। For your practice, you are given an assignment, discuss the chemoselectivity of the following 2 reactions. इसमें बेटे आपके पास 2 आइडेंटिकल फंक्शनल ग्रुप्स हैं, उनकी आपने chemoselectivity जो है वो डिस्कस करनी है, इनकी एप्लीकेशन ढूंढनी है कि कैसे आप फर्दर और आइडेंटिकल फंक्शनल ग्रुप्स को अप्लाई कर सकते हैं ऑर्गेनिक सिंथेसिस में। आपने इनकी अच्छे से प्रैक्टिस करनी है। इसके लिए रिकमेंडेड बुक्स हैं स्टुअर्ट वेरन की द डिस्कनेक्शन अप्रोच बाय स्टुअर्ट वेरन एंड द ऑर्गेनिक सिंथेसिस बाय क्लेडन एंड ग्रीव्स। आप इन दोनों बुक्स को कंसल्ट कर सकते हैं और इस लेक्चर की अच्छे से जो है वो प्रैक्टिस कर सकते हैं। Thank you so much, dear students. If you find any question, you can discuss in the classroom. Allah Hafiz.